Hello and welcome to our series covering Kubernetes. So, why Kubernetes? Well, it's probably fair to say that most administrators these days have already heard of Kubernetes. If so, you'll be aware that Kubernetes' primary purpose is to simplify the management of large container-based deployments. You are probably already aware how easy it is to run a single instance of an application using Podman. But it's unlikely that you'd deploy into production on a single node. So imagine having to manually deploy and manage this across your production cluster. Keeping track of and managing all of the individual container states would most likely very quickly become a nightmare administrative task. That is what Kubernetes was designed to simplify. Something it achieves by acting as an interface between the underlying cluster machines and the application or applications that you've deployed onto them, thereby freeing the DevOps team from having to manually monitor and react to any infrastructure-related issues that may arise. This includes events such as horizontal scaling, so bringing new nodes online as the load fluctuates or during the rollout of application updates, load balancing, ensuring that the load is distributed across the cluster evenly, self-healing, restarting an application as, when or if needed. So what's not to like about a system that reduces the likelihood of getting a panicked midnight call to resolve an outage? It can also help to automatically roll out new updates to existing deployments, either across the entire cluster or even a subsection of the cluster for testing purposes. If that isn't enough to persuade you of its usefulness, and perhaps the fact that it has an open architecture which numerous vendors use to provide plugins covering things like storage, networking, security, etc. Kubernetes is even open with regard to the container runtime you can use. We use Podman in our case, or alternatives such as Cryo, Docker, etc. So, what architecture do you need to use Kubernetes? The minimum requirement is a cluster of computers, also known as nodes. So, what defines a node? Well, a node is a machine which may be virtual or physical, where an operating system and Kubernetes has been installed. In the Kubernetes world, each node is assigned to one of two roles, which are known as planes, either a control plane or a workload plane. This means that your cluster is divided into two groups: the control nodes, which run the control plane Kubernetes components. Their role is to control the whole of the cluster. The worker nodes, which together comprise the workload plane. Their role is to run the applications deployed onto them. Both of these planes combine to make a working Kubernetes cluster, but how do they achieve this? Well, the control plane acts like the cluster's brain and can be a single node or more usually a cluster itself. So let's look more closely at one of the control node's Kubernetes components. It has an API server which processes and validates RESTful requests and executes the operations. A scheduler process. This controls and tracks which worker node each application is executing on. Controller process. These act on deployed applications via the API server requests. etcd. This undertakes all of the networking functions and routes network traffic. Remember, the control plane node or nodes do not run your application. That is what the work plane node's role is. Each worker within a work plane is instructed by the control plane to run, monitor and provide connectivity for any application deployed onto this Kubernetes cluster. So now let's look at one of the worker node's Kubernetes components. This starts with kubelet, an agent that allows nodes to communicate with the API server. The proxy provides network functionality including load balancing, routing, etc. Pod. This requires a container runtime, which is Podman on Oracle Linux or Oracle Cloud Native environment installs, but can be any other runtime on other Linux releases, for example, Docker, etc. You wouldn't be the first person who may be thinking all of this seems to be very complex, and indeed it is. Kubernetes is well known for having a very steep learning curve. However, it repays the time invested through the functionality that it delivers in the day-to-day management of your deployed applications. In short, if you have a medium to large microservice-based application to be deployed, then Kubernetes is probably well worth the investment in time, effort and expenditure for your admin team to learn. However, please remember that whilst Kubernetes is designed to make managing complex application deployments easier by managing and monitoring availability, etc., it is not a big one-stop shop for everything. This means that there are some limitations as to what Kubernetes can manage for you. For example, it cannot create the nodes used for the worker or control plane nodes. These need to be created and then made available for Kubernetes to use. It cannot install itself onto a node. Someone else has to install it. It cannot create any other resources that may subsequently be needed for use. For example, it can't install file systems for storage, etc. Kubernetes is, however, extremely flexible and very resilient at managing complex microservice-based deployments. This completes this overview of what Kubernetes is and how it can help you. Many thanks for taking the time to watch, and be sure to keep an eye for further installments in this series. For additional information about Kubernetes, please access the Oracle Linux documentation or Oracle Linux Learning Library.